If you have coded in C, C++, or maybe Java, you must have come across compilers. And if you don't know what a compiler is, a compiler is just a tool that converts the source code that developers write into machine code that computers can understand. Now, in order to convert the source code into an executable program, the compiler has to go through 4 phases: pre-processing, compilation, assembly, and linking. Let's talk about the first phase. If you are a C or C++ developer, you surely know about the preprocessor directives, the include statements, the define statements, and etc. Now, regardless of the functionality of each preprocessor directive, the compiler handles those statements first, before it starts to compile the source code, creating an expanded source code, and it also removes all the comments written in that code as well. Then we step up to the next phase, which is the compilation phase, where the compiler translates the pre-processed code into assembly instructions. Now, you might wonder why a compiler has to translate the source code into assembly. Why couldn't they just convert it to machine code instead? Because it is much easier to make sure that the compiler is working correctly by examining assembly code rather than machine code. Assembly stage. During this stage, an assembler takes those assembly instructions and translates them into actual machine code. Last but not least, we have the linking stage. This is where the magic happens. The linker organizes the pieces of object code, ensuring functions in one piece can call functions in another. It also adds necessary pieces like library functions. And there you have it, the journey from your code to a running program. Understanding the compilation process can empower you as a programmer. If you found this video helpful, don't forget to like and subscribe for more programming insights. Thank you for watching, and I'll catch you in the next videos.